Welcome to the latest Emerging Technologies event from the Royal Academy of Engineering. Welcome to the people in the room with us, welcome to the people watching the live stream, and welcome to people in the future watching the recording of the live stream. I'm Timandra Harkness, and it's a great pleasure to be here with a panel of 4 terrific speakers. Now, the Royal Academy of Engineering Chair in Emerging Technologies delivers public benefit from innovation and engineering excellence. And what we have this evening is 4 awardees of that chair to talk about their work, what they're doing, and more importantly, perhaps, why it matters and the impact that it's going to have in the world. And we're very excited to be hosting this event in the University of York while it's celebrating its 60th anniversary. Today's discussion is going to centre on robotics and autonomous systems, as I say, particularly looking at the impact of these technologies. And I'm very pleased to be joined by 4 brilliant panellists. From my right, we've got Professor Ana Cavalcanti, Professor Michael Fisher, Professor Jonathan Rossiter, and Professor Dan Stoyanov. I will introduce them in more detail in just a moment. When you think about the future, robotics and autonomous systems are often at the forefront of this imagining, along with artificial intelligence. We've got government analysis that suggests the total economic impact of robotics and autonomous systems, or RAS if you want to get technical, is going to be in the region of 6.5 billion, well, 6.4 billion for any engineers watching, by 2035. Sorry to only go to 1 decimal place there, but you know, what you lose in precision, you gain in accuracy. That's what I always say. But obviously, ideas about what the impact will be on the economy are different. Some people are worried about it taking away jobs. Some people think this is a great thing because with new emerging industries, that will actually bring more jobs and jobs we've not even imagined yet. So I hope we're going to explore some of that this evening. To define our terms a little bit, and I hope the 4 of you will maybe pick up on this and probably put me right as we go on this evening, but we can think maybe of robotics as being about a particular machine or device that does a particular task automatically without human supervision, whereas an autonomous system maybe is something that can adapt to changing circumstances without human supervision and do different things. The 2 are obviously related, and then you've got artificial intelligence as part of that picture, which can be anything from a glorified predictive text machine to a godlike superintelligence that's going to be to us as we are to ants. We're not going to cover all of this within the next hour, by the way. I just want to give you an idea of the scope of the subject. So one of the things that is a particular concern, especially around machines that can do things unsupervised and change what they do without supervision, is the issue of trust, regulation, safety, perhaps. And this is something we will definitely be talking about this evening. But on the other hand, too much regulation can hold back innovation. So Innovate UK have talked about the UK both sitting on a robotics gold mine, potentially, but also that regulation and certification will be an important part of that, so that we can move forward with trust and confidence. Now, if you want to ask questions of the panel, I will be starting off. I have plenty of questions of my own, but if you want to put questions in, and this applies both to you in the room with us and also to people joining us in the live stream, you can put questions via Slido. I think the details are all here behind me. There's a QR code and also a website. Feel free to put those in at any time. They will come through to me, and I can feed them in, although I am planning to abuse my chair's privilege and monopolise the panel initially. Obviously, if you are watching the recorded event, you won't be able to put questions in via Slido unless you're sufficiently far in the future that you've invented time travel, in which case feel free to come back in time and put some questions, but please don't send a killer robot back in time to wipe us out. And for people in the room, but probably not on the stream, we're not planning to have a fire alarm during the next hour. So if a fire alarm does go off, there may be a fire. So please follow the University of York people out to a safe place. I think they're wearing purple, but in the darkness and confusion, just do what you're told, basically. So there you go. I think that's all the necessities covered. So let me introduce the panel in a little more detail, and then get on to some questions and some answers. So starting over here, Professor Ana Cavalcanti is a professor of software verification at the University of York. That's why she knows her way around the building, and none of the rest of us do. She's pioneered work on industry strength techniques for design and verification of software, was awarded the Chair in Emerging Technologies in 2018, and her focus is software engineering for robotics. So perhaps it's fair to say that when other people deal with the limbs and bodies of robots, you're interested in what's going on in. I'm not even going to say robot's mind. I mean, there's a whole can of worms there, but let's come to that in a moment. But also, as well as being director of the RoboStar Centre for Excellence on Software Engineering for Robotics, you're also the academic lead of the Institute for Safe Autonomy. One of them. An academic lead for the Institute of Safe Autonomy, which is definitely something we shall come back to. Next, we have Professor Michael Fisher, who's Professor of Computer Science at the University of Manchester, so the other side of the mountains, who was also awarded his chair in 2018. His focus is on responsible autonomous systems, and at some point, I am going to ask you, Michael, what an irresponsible autonomous system looks like, because as usual, that sounds dangerous and more fun. But he chairs the BSI Committee on Sustainable Robotics and co-chairs the IEEE Technical Committee on the Verification of Autonomous Systems. And also, book plug, you have a book coming out later this month, I think, entitled Verifiable Autonomous Systems. Available in all good bookshops and a couple of bad ones. See, if we'd had some here, you could have signed them. Well, next time. Next we have Professor Jonathan Rossiter, who's Professor of Robotics at the University of Bristol and head of the Soft Robotics Group at Bristol Robotics Laboratory. I take it it's the robots that are soft and not the group.
Well, a bit of both.
Bit of both.
We're all a bit soft.
Well, it's another thing we'll come on to. So his chair focuses on smart materials and mechanisms for ubiquitous soft robotics. And his work varies from robots that eat pollution to artificial organs and medical devices. And besides publishing many articles, Jonathan has his own TED Talk with over 1 million views. Take that, YouTube influencers. And finally, Professor Dan Stoyanov is newly awarded Fellow of the Royal Academy of Engineering, having pioneered the development and translation of vision algorithms for surgical scene understanding, surgical data science, and robot control. His chair focuses on robot-actuated imaging skins. I'm not entirely sure exactly what that is. I'm going to ask you that when we come onto it. Is this your fellowship, is to find out what the title means? He's a Professor of Robot Vision at University College London and Director of the Wellcome EPSRC Centre for Interventional and Surgical Sciences. In 2019, he co-founded Odin Vision Limited, a spin-out developing medical devices powered by surgical AI. Wasn't Odin the god that only had one eye?
Yes, but it was the all-seeing eye.
Oh, I like it. Good. Okay, so as you can see, we have an amazing panel, and to be quite honest, I could spend an hour talking to any one of them about what they're doing, but we don't have that much time. We have about an hour in all, maybe slightly over. So I'm going to guide the first part of the discussion with my own questions, and then we're going to use as many as possible of the questions that come in via the Slido. So ask at any time. But I wanted to start off with a question initially for you, Michael, although the others of you may want to come in as well. Your work focuses on responsible autonomous systems. And as I say, I'm curious about what an irresponsible system would look like, but maybe we'd go back a step here. And what is the advantage of developing an autonomous system in the first place? Why not just use robots that do exactly what you have programmed them to do?
So we want to develop robots to work in places that people wouldn't go, and often these places are distant or hard to communicate with. And if you want to have a human controlling these systems, it's quite difficult. Have you ever tried controlling a toy aeroplane or a toy car remotely? It's difficult, and imagine you can't see the vehicle as well. It's really hard to control this. So actually, remote control of these devices, whether robots or vehicles, is very difficult, especially in complex environments. And they work much better if they have their own way of controlling things. They can react to what's going on in that situation, hopefully make better decisions about what to do, and be more reactive. A sort of very extreme example of this is, imagine you have a robot that's on Mars, and it's walking along Mars and something happens. If it takes 10 minutes for a ground controller to tell it what to do, something's happened by then. So actually making it autonomous gives it more flexibility and control, and all you have to do is make sure that autonomy does what you want.
It's interesting that you said walking on Mars,
Okay.
because I was going to say, is it a mistake? I mean, I think like a lot of people, when you say robot, my default is to think of a robot that's shaped roughly like a person with, arms and legs and a head, and yet actually a lot of actual robots are not remotely shaped like a human being. So how many autonomous systems really are something that might resemble a living creature?
So lots of the ones I've seen don't look like that at all. A lot of them are wheeled devices, for example. There's an awful lot of that, and perhaps I should have said driving on Mars instead. Those types of things. So the whole range of devices. And as we get onto Jonathan's thing, very strange devices you might not expect.
Okay, so what are your strange autonomous devices, Jonathan?
Almost anything, really. Anything that's soft and squishy. I think this raises a really important question here. If you want a responsible robot, then maybe you want to be able to trust it. And trust is a core concept in robotics. And we find that there's no point in making a robot if the user doesn't trust it. If the user trusts it, then they're more likely to use it. The trouble is when you make robots that don't look like anything you've seen before, which is the kind of thing that we look at, a mound of jelly that moves around the floor or crawls up the wall, that in itself can be an autonomous robot. But if you're a new person to that kind of robot, how do you trust it, and therefore how do you have confidence in it? It could be really good at doing the job, like cleaning windows or something like that, but it's so outside your frame of reference that you need to have this kind of study that Michael does to explore what that means and the impact that it has on you.
I have to say, I would find it quite hard to trust an autonomous blob of jelly that was moving around my house.
Once you're used to it, you get used to it.
So I think this brings us very much onto your work, Anna, with things like verification and systems of trust. So tell us how the work that you're doing should make me feel more confident in some of the machines and devices that are being developed.
Jonathan quite rightly said there is an issue of trust, and trust involves several aspects of the working of a robotic system. It goes from appearance, and there are even ethicists that would say they shouldn't look like humans because there is a tendency of people to associate a personality to what is actually a machine. So there are aspects like that. What we focus in RoboStar is on the aspect of the development of software, development of the code. Every robot, every autonomous machine will have a strong dependence on the code that runs on these machines. And what we are facing is the challenge to develop techniques that the roboticists, that the practitioners can use to then provide guarantees, provide evidence for all sorts of stakeholders, the users, regulators if they apply, that the properties, that what you expect of that machine, whatever they may be, they hold, that you can have some sort of confidence in the software that's running there. And today, people, first thing they do is to sit down and start writing the code. Generalization, but that is in many cases what you see. And what we want is to take a more engineering approach to the development of that code.
Can I say something about trustworthiness,
Yes,
since you brought it up? I mean, I think there's a step change in what we mean by trustworthiness when we come to autonomous robotics. It's a big step. So your normal device is your toaster. You trust the toaster if it reliably makes the bread go brown in the right way. That's fine. When you step towards autonomy and you have this system making its own decisions that you can't necessarily control, then you have to not only think it's reliable, but actually believe it's working for your benefit. And maybe you don't trust these things because you don't quite know what's inside this thing. If there was some way of getting inside the blob of jelly that Jonathan has and working out what it was doing and guaranteeing that it's doing the right things, then you might trust it more. So it's the decisions it's making, it needs to be transparent about exactly what it's doing as well. for you to trust this thing.
So yours could be physically transparent and also transparent in terms of how they work.
As long as you project your mind into it to imagine what it's like being a jelly blob, yes.
Well, I mean, this is a huge question. Thank you for all of you for getting on to the huge questions immediately. I mean, are we already getting onto the point of if you have machines that are genuinely autonomous and you talk about them in some way as being responsible, are they responsible in the sense that we're responsible, that you know, Dan, if you run me over with your bicycle, then I don't blame the bicycle, I blame you. But if you say, well, it was an autonomous bicycle, maybe the bicycle is responsible, and I blame the bicycle. I mean, is it premature to look at autonomous systems and say we want a similar kind of accountability that we have for us?
I think it's a really important question. I think it depends on the specific system and what role it fulfills in society. So if you look at healthcare robotics or surgical robotics, for example, the issue of liability is a very important one. And that's why autonomy at the moment is perhaps not there to the level that it could be. So you have systems that potentially can have a lot more autonomy than they do, but the surgeon is liable and responsible for everything that those systems do. So in some ways, the robotic system is just a very, very advanced instrument. And that liability, that trust, that real kind of adoption is one of the, and regulation also is one of the key barriers to making some of those systems more autonomous. Now, whether we need to is yet another question. So me as a patient, I would rather the surgeon controls the robot that's doing the procedure on me. But perhaps over time, the robot will become more accurate for certain things or will become a very good assistant to the surgeon, in which case I would like the robot to have that autonomy. So I think there is also a societal transition from where we are today to where we may be in 10 years' time. But of course, I think we're nowhere near. I don't know if you've seen the movie Prometheus and this capsule that does all sorts of autonomous things. So when you need a procedure done, we're not quite there yet. At least not in healthcare robotics. We don't probably need it in our mainstream healthcare service. But if you were talking about systems driving on Mars, walking on Mars, then maybe that's the setting where that will be playing a very important role. And our flexibility and trust, because you don't have another solution, I'll be very happy to trust the robot there because there isn't a surgeon to help me.
Well, here's an interesting question to throw out to the audience maybe. What would you be happy with if you had to have an operation? Would you rather have a robotic autonomous system that was highly, highly accurate, like 99.99% accurate with getting things exactly right, but where nobody essentially was morally or legally responsible for it, or a surgeon that was measurably less accurate but felt very personally responsible? So anyway, you can go away and think about that and feel free to answer on the Slido. So Jonathan, you also work, I think, in medical and healthcare settings. So what kind of difference are robotic and autonomous systems going to be making to healthcare over the next, I mean, let's throw it out, say over the next 30, 40, 50 years?
Yeah, well, the whole environment is going to change. So, I mean, if you take this auditorium here, there are no robots in here. Everything is fixed. It's very conventional. But we view that robots are going to change our environment. They're going to change so that robots are around us. They're going to be with us. They'll be sitting next to us, of course, as care robots. So care robot can help immensely in the care of somebody who's older, who has a disability, even just to bring a cup of tea for somebody who's at home. It's really a very great advantage. But then the robots don't just need to be with us, they can be on us as potentially exosuits and exoskeletons. And we study a lot of robotic clothing. So my clothing is very stylish, I'm sure. But the general design of the clothing has not changed for hundreds of years. So we're at a point where we can have a revolution, and we're pushing for the revolution in clothing to make the clothing robotic to give you power.
Haven't you got a project that sounds extremely Wallace and Gromit? And I mean, Wallace and Gromit are also based in Bristol. I'm starting to...
You see the inspiration?
but which way? I mean, who came first? It's not called the wrong trousers, is it?
It's not called the wrong trousers. It's called the right trousers, of course, because we are trying to make the right kind of trousers that when you get up in the morning, you can't get out of your bed, You easily put them on, you press a button, just like Wallace and Gromit, and then it gives you power to walk around. And it seems trivial, but you get to a point in your life where you may be living alone or you're living with somebody else, and you cannot get out of your chair easily to go to the kitchen to make a cup of tea. So at that point, if you could just use your trousers, press the button, and that enables you to make your cup of tea, have your cucumber sandwich, then you have kept yourself where you want to be with a good quality of life, independent for longer. And that makes a huge difference, not just for people's quality of life, but also for the cost to the health service and the future robustness of our economy.
Go on.
So I was going to follow up on that. I mean, I'm very old, so imagine in 20 years' time, if I have a choice between sitting on my own with nobody visiting and no social care workers coming at all, or having a robot assistant that not only helps with that, but does health monitoring, potentially even social interaction as well. What did you think of the match last night? What did you feel about the program? Then maybe I'd rather have that than nothing at all, if that's the choice.
But this is an interesting point, because wouldn't you rather have an actual human?
I would rather
at
have
least
an
to
actual
talk to you, if not
yes.
to get you
Yes.
out of bed and do the
I would rather have an
practical
actual
things.
human. That might not be a choice.
But is this not a danger that instead of solving problems with social solutions, if you like, that we will go instead for an impressive, very impressive technological solution, because that's the way we're thinking? Is there a way to incorporate into the development of robotic systems the question of, well, would we rather have a human doing this or a robot?
So it's not, sorry, did you want to say? Okay, so it's not exactly building robots, but there's a lot of work around the societal aspects of these things. Do we actually need these things? Should we actually use these things related to both sustainability and to societal need as well? Could we do the same thing with people actually doing it, or less technology? We shouldn't necessarily go for the high technological solution.
I'll come to Anna now.
So, one thing doesn't need to exclude the other, and that we as a society need to decide what's the best way. And I think it passes also for, again, going back to the point of trust, because I think it's so important. I think Dan is absolutely right, but if we're looking at the future, we are going to move towards these robots that are very close to us, perhaps even we'll be wearing them. And then we need to understand, is it the bicycle or is it the cyclist? And we cannot let the manufacturers off the hook. They need the tools, they need to have the support to be able to provide some sort of guarantee, but they have to have the responsibility. Even they need to have the responsibility to be able to tell their users, these are the conditions under which you can use my robot. And under those conditions, they have to have the responsibility. If the user misuses it, if the surgeon makes a mistake in using the machine, okay, user error. But that barrier needs to exist. The responsibility needs to be shared. We can't let the manufacturers off the hook. We have to support them. But
I completely agree. Everyone has a responsibility. Initially, what I was going to say was following up to Jonathan's point with the right trousers, and obviously trousers need to be reusable, and probably maybe we as a society are going to change the way that we live, and we center humans around the trousers so that we can share trousers, and maybe that will encourage social interaction. So ignore my silly point there. I think Anna made a much better point. Of course, responsibility needs to be shared, and we as humans will have liabilities and responsibilities to interact with such technology in a responsible way. And obviously, the technology and whoever is making it has a verification and validation duty to make sure it does what it's designed to do.
I love the idea that we're all going to share trousers, and the future will be brought together by sharing robotic trousers. This is taking a lot of very unexpected turns. Some of the questions already come in the slide are great, so I am going to come to one of these, actually, because I think it gets to a heart, and again, one of the really big questions is, will a system ever truly be 100% autonomous without any human intervention? And maybe there's two questions here. Is this possible, and is it desirable? So you're quite confident that it's, yeah.
Absolutely. But An autonomous system doesn't need to be very complicated. So you can look at biology for analogies in this case. So we've got very complicated organisms like us, the most complicated, and we have clearly got autonomy and intelligence. But even the smallest organism that's motile and moving around, bacteria, microorganisms, they have reactivity, autonomy, and they do an important job of work. So even the smallest robot, and we're looking at making robots that are of that size and of that kind of capability, will have autonomy. Of course, it doesn't have any human interaction with it at all. We've set the ball running. It does an interesting and important job of work for us. And so there's no need to worry about it. That's my confidence.
You're very confident.
So pushing back slightly on the question, it depends what the questioner means by human intervention, because somebody intervened to design that system at the beginning. So if it means that there's no human interaction during its lifetime, after it's been deployed, then yes, there's lots of those. There could be lots of those. But no human intervention, not even right at the start, not even setting the limits, not even setting the ethics of this thing, not even setting the boundaries.
Well, I am going to assume, that it's an anonymous question, so we don't know. I'm going to assume that they meant after it's been created and set in motion.
So let me ask you another question then. It all goes back to what is autonomy, and I'm not suggesting we discuss here because we could spend the rest of the night talking about that. But I would ask, if a robot needs power, is it fully autonomous? If it needs, even if it perhaps goes back to its base and charges itself, is it fully autonomous? It will get into trouble if there is a power cut.
Okay, what if it's got solar panels?
Okay, that's what I'm trying to say. There are so many things. There are people that are, I don't have any expertise on this. There are people that are developing robots that can eat.
See,
Yeah.
I'm not sure I'm at all comfortable with developing an autonomous robot that eats. I mean, is it a vegetarian?
They
Is it? Oh, actually, no. I just say that if it eats snails, it's welcome. I'll have one in my garden.
Lots of energy in a snail.
Honestly, seriously, if anybody watching the stream, anybody in the room, any of the panel can invent a robot that will just go around my garden, eat all the snails, I'm there. You can take all my money. I haven't got much, but it's all yours. Okay, I feel we should move on slightly. I mean, you're right. The autonomy question is very interesting and huge, and comes back again to that question of regulation and trust. But I want to move on slightly to kind of another aspect of societal impact, which is about the idea that robots will take our jobs. And I know, I mean, there are a lot of very different opinions on this, and it seems to me that the answer depends not, like so many things, not so much on the technology, but on the context, that you can look back to previous industrial revolutions and say, okay, well, you know, all the horse people lost their jobs, and then they all got new jobs making motor cars, and then planes, and then there were 1 million jobs in aviation that nobody foresaw. But of course, that was a very different economic time. There was a lot of expansion, economic expansion of industries. Possibly we're not in that time now. So how are you feeling about are these going to be new industries that will create lots of new jobs, people will have lots of rewarding work, or are you concerned that, in fact, a lot of especially lower skilled jobs will be taken away by robots, which are, you know, they can work all the time, they're cheap, they don't go on strike, lots of advantages from an employer's point of view. Should people worry? And if so, which people should worry? Can I throw that to you initially, Dan?
Sure. I'm personally optimistic. I think these systems are going to assist us. So if I look at my house, if I decided to take out the dishwasher in order to create more jobs, I think there'd be a mini revolt. And so, you know, I really think automation and systems like this can have a net positive effect. That doesn't mean that as a society we shouldn't prepare and we shouldn't consider and we shouldn't think through how we need to reskill, upskill, or change certain jobs, because they are going to be impacted by this technology. So I think we do have a social responsibility, but I think there is an opportunity to have a net positive on society.
Okay, other thoughts? I mean, if we are just going to have to learn to do different jobs, what kind of skills, or maybe even not even skills, maybe there's no point in humans learning skills when robots can do specific tasks. Maybe we have to learn attitudes, mindsets, capabilities. What should the young people of today be thinking? I need to focus my education this direction if the machines are going to take over a lot of the routine tasks. Go on.
I think that the environment is changing in which we live, and the robots are not going to be separate from us. And the barrier between us and the robots is coming down. And the reason for that is we have better systems, we have better verification, we have better understanding of how these machines can be autonomous but safe with us. So that changes the way in which we interact with them. So if you take a manufacturing environment, the robots over the next 10 years or so will be coming into that environment where the humans work, not replacing them, but working with them. So there's a big impetus at the moment for cobotics, the collaboration of the humans and the robots. And there's talk of this being the next revolution. It's not replacing humans, it's humans working with the robots doing the kind of work that humans find very boring, mundane, but they're doing it so that then they can work with the humans on more exciting, more interesting work. So you can say making a cake, for example. And if you've seen videos of people making cakes in a factory environment, it's slapping on the icing, slapping on the icing. It's a very repetitive thing. But in the UK, we are very good at high-value manufacturing, making the precise high-quality cake, for example. And the robot can help with that. Instead of being a mass manufacturer, it becomes very specific, very high quality, because the robot is working with the human. Taking down this barrier is going to be really exciting, I think.
So I think related to that, and almost going back to my robot in the home looking after me when I'm old, I think the robots will do, hopefully, the mundane jobs, but I think we need people to do the more social aspects. So people who understand about communication, about empathy, about caring for people, those are going to be even more valued than they are now when we get to that stage. So I think that's a good direction to go in.
I think the answer is application dependent. In different areas of application of robotics, the impact will be different. I have a view that we need to be pragmatic and we need to be responsible, because we are not going to stop the evolution of technology. I've said this in public before. I think I read somewhere that the first time that people worried about humans losing their jobs because of machines were back with Elizabeth I, when they were worrying whether we were going to have sewing machines and whether the tailors were going to lose their jobs. And of course, we know where we are now. So we're not going to stop the evolution. We need, as a society, to be responsible to help the people that might be left behind. And there will be a lot of, you are asking what the new generation need to learn. I think I am very enthusiastic for the new generation of computer scientists to learn to apply this software engineering and, well, the engineers in general, to learn to apply these techniques that we are all developing to the benefit of the society going forward, to get the right education, to be able to contribute.
Okay, so to pick up on something you were starting to go towards then, a lot of previous technologies have exacerbated some existing inequalities or even produced new inequalities in some cases. But then in other ways, you can see that technologies have reduced inequalities. So for example, when jobs became less dependent on physical strength, it became much easier for women or people with disabilities to come in and do jobs that previously had demanded a fully grown man with a lot of muscular strength to do them. So now, I mean, some of my ancestors worked in the docks, literally in the holds of ships, carrying massive lengths of timber up out of the holds of ships physically. Now, that's not really a job in the UK. So there are fewer jobs, but it's people driving cranes, lifting containers, and lots of people can do that without wearing their bodies out. So where do you see the dangers that robotics are going to exacerbate inequalities, maybe even between countries, and where do you think it has the potential to make things more equal in terms of opportunities?
Absolutely. If you take the kind of wearable soft robots, wearable robots that help you to move around, that is a game changer for people who've got movement disabilities. So in the UK, something like 17% of people have disabilities, and a large proportion of those have got movement issues. Bad knees, bad hips, bad shoulders. Being able to put on these clothing and then to move them around means that you level the playing field. It raises another question, though, whereby if you've got a level playing field and then someone wants to take advantage of it, perhaps they could make the playing field a little bit less level. And we talk then about augmenting humans. So we've got these kind of two concepts of if you have a problem, disability, you're feeling a little bit unwell, you get restored back to where you should be. And then there's a question about, well, what happens if you go a little bit further in your restoration and you start augmenting yourself, or you augment yourself with your sensory capabilities, your physical capabilities. Same is true with AI, of course. Those are open questions. We don't have an answer for it, but I think there's things we should discuss as robotics researchers.
Okay, so Dan, what do you think? Are we going to use robotics to, in fact, enhance our direct personal capabilities in a way that could either level us up or be to the advantage, perhaps, of individuals who can afford to buy these things?
Probably we'll do both. So if I think about the area in which I work in surgery, I think robotic instrumentation, for example, will allow surgeons to be more equal because some of the dexterity factor may be equalized because suddenly the instruments do it for you or they do components of that for you. So I think that may enable better healthcare treatment for the patient, which obviously is something that we want. So I think there'll be an equalizing positive factor in that sense. Now, of course, if we say that some doctors are going to be able to use these instruments, but others can only use the traditional instruments and the traditional scissors, then that will create a tiered system where some people will receive the best care or the standardized care and others won't. And so I think that's where it's really important to engage with policy and with regulators in order to ensure that we mitigate some of those risks as much as is possible. Of course, economics is a big factor in this. But I think there are potential policy decisions that can make sure that we don't go from one day having everything being done manual to the next day having everything being done robotic, let's say. There may be safe transitionary processes that allow that process to be more gradual and therefore impact society in a less sort of cliffhanger way.
Well, this is interesting because, I mean, you two both work in a sense in the field of working with regulation and trying to set up standards and systems and transparency. Is that kind of very, very broad, almost global societal impact something that can be addressed with regulation or internal industry standards? Or is that the kind of question that you just have to leave to politics and social movements? And I mean, I suppose what I'm asking is, what is the scope of regulation and standards for mitigating undesirable impacts? Or where are the limits of that?
So I think for some of the standards that I'm involved in, they're not very prescriptive, they're more like guidelines. So at least these are guidelines that you should follow when developing robotic systems. So ethical guidelines or sustainability guidelines. So you should look at these things, and when you're developing these systems, you should think of the unintended impacts, the ethical harms, if you like, the sustainability issues while you're developing these things. And they're hard to enforce, so they're more like guidelines, but at least they're there and they should be referred to by the people who are developing these systems. So it's hard to have a precise, you must do this thing, but these are a list of a whole catalogue of things you should consider when you're developing and deploying these systems. You know, will it affect employment? Will it affect people's sustainability or ethical aspects?
So it's a bit more than just saying, don't build anything that's going to blow up. In the same way that you might regulate what goes into food, for example, or cars. So it's a bit more than that. It's a bit more like here are some ethical stages you should perhaps go through in the course of developing.
Yeah, some ethical considerations you should have. Are you building a robot, for example, which when somebody uses it, they will think it's alive, and they will think it loves them, and they will think it likes them? You have to be careful about those types of things, so you should at least consider this. Is it the same as a human has a pet and thinks the pet loves them? The human has a robot. Does it think the robot loves them?
Whoa, these are huge
No, but
questions.
you should consider that when you're building these systems. Are you building it, as Anna said, you don't necessarily want to build a robot that looks like a human. Do you want to build a robot that looks like your pet and acts like your pet? And then you think it's the same as an animal. They're ethical questions that you should consider when you're doing these things.
So Anna, yeah, you referred to this earlier, and we kind of bumped over it at that point, but maybe it's the time to come back to it. People arguing that actually we should design autonomous systems that are machines to be very different from people or even animals perhaps, so that we interact with them differently. Because we do tend to personalize. I mean, I know this is partly the design, but we do tend to personalize even the assistant in your phone or things like ChatGPT. We are encouraged to interact with them as if they were on some level people.
I've given name to my vacuum cleaners because they're autonomous, yes. So
What do you call your vacuum cleaners?
Albert, Elizabeth, you
Okay.
see.
Do they do what they're told when you address them by name?
Certainly.
So, well, this is okay. So this is a bit contradictory, though, because you were saying that I think, unless I got you wrong, that this is quite dangerous, and we should maybe avoid personalising technology, and yet you give it names. So, do you really think it's a problem if technology is designed in a way that we interact with it as if it was?
I do think. I think I am not in that danger because, yeah, it's just a joke with my vacuum cleaners. But if you're talking about, we've been working in New York with case studies like a robot to assist people that have perhaps mental difficulties or physical disabilities as well to get dressed. And so people, when get to the certain level of vulnerability, they may get confused, and we don't want the reliance on a machine to be stronger than it should be. I think that's the kind of question that Michael was alluding to. So yeah, there is the joke, and there is also the serious concerns that one should have, and then these standards need to address that.
I think it should be transparent what this thing is.
Yeah.
That it's a machine, essentially, rather than just your friend.
Is there a danger that we trust machines and systems too much? That we actually say, well, it's been built, all these standards, these terribly clever engineers have tested it. I can have 100% reliance on this robot that's going to come in and help me get dressed in my magic trousers, and I'm never going to question anything it does. Are you saying that would be a mistake? Or if all of you work really hard and really carefully, can we ever get to a point where we can go, look, I can just 100% rely on this technology?
Do you want to go first?
Okay. I'll go back to the issue of responsibility again. There cannot be unreserved reliance. You're using a machine, or you need to understand what that machine can do for me, under what conditions, and that needs to be known by the professionals, communicated to the users very clearly, and then the responsibility is clear. It's not about, I can trust entirely, it's a machine, what its limitations are, what are the operational conditions, then manufacture the responsibility to make sure that it is working well in those operational conditions, and I'm using working well to avoid any sort of jargon here. There will be lots of concerns that you might have, and then you have the user's responsibility as well. That needs to be shared.
So so nothing's 100% safe, so you have to accept that things will go wrong. The question is, do you still trust this device when things go wrong? You trust your friends or your relatives because even though they make mistakes, you believe they're doing the right thing. So actually trying to expose why it's doing what it's doing and try to expose the intent of this thing is very important to the trustworthiness. So, okay, an example I often give is a robot comes and drops a hammer on your head. Yeah, that's bad, it hurts, but there could be two reasons. One, it deliberately tried to hit you. The other, its gripper wasn't very good and it dropped it. So from a safety point of view, it's exactly the same if you got hit by a hammer. But from intent and trustworthiness things, those two things are very different because you might trust the thing that was trying to grip and just failed, just saying it's slightly unreliable, but it wasn't trying to hurt me. Whereas the other thing was really trying to hurt you. So actually understanding why it's doing things is a key aspect here. And you can trust things that go wrong as long as you believe that they're doing for your benefit, they're doing the right things.
Well, this is really interesting, and there is actually a question here somewhere, I can't instantly find it, about intent, about whether you can trust a system that isn't conscious, and whether, in fact, you can talk about a robot or a system having intent. Because, I mean, obviously, all of us here, we have a certain amount of intent, and if I hit you with a hammer, unless I had just not gripped it enough because I didn't have my magic gloves on, then I think you would rightly go, what was I trying to do here? Why am I trying to hurt you? But if a machine does it, as you say, you don't automatically ascribe intent to a machine. Are we going to, if a system is autonomous, does that mean we should think of it having intent?
So some of the research I'm doing is trying to build systems that can expose exactly what it's doing and why it's doing it. So you can actually get the intent out of the system. So if you think of the Terminator films, which this thing's going around killing everybody, but if it had a little screen on its chest that said exactly what it was trying to do, truthfully, then you'd either be really scared or really, really comforted because it wasn't trying to kill you, it was just trying to move you out of harm's way.
Is this the difference between Terminator 1 and Terminator 2?
Which one's Terminator 1? But the exposure intent...
Which film am I in here?
The exposure intent can be done if you build these systems in a way that the decisions are transparent and the reasons for doing things are transparent within the system. If you build it all as a very opaque black box, then you don't know what's going on at all. But you can build this system so it can expose why it's made these decisions, and that can hopefully give you more ability to trust these systems.
Or to know that you shouldn't.
Or to know that you shouldn't, because it's transparent.
I can imagine definitely some people out there thinking, if only you could do that with human beings and have a screen on the front that told you what they were thinking and why they were doing what they're doing, as people in the room nodding as well. Okay, I would love to stick with this, can a robot have intent? But lots of questions are coming in, and I do feel I should at least try to cover some of them. So look, here's a question which I think is quite... it's a big question, but it's quite practical in terms of the potential impact of these technologies. How can we scale up autonomous systems to operate in larger complex environments such as smart cities without compromising safety or performance? And there's another related question, in fact, about autonomous vehicles, which I was thinking of slightly when you were talking earlier about a future in which humans and autonomous systems or robots will be alongside each other all the time. Because I remember being driven in an autonomous car in, in Singapore on university campus, everything very orderly and neat, and that was fine. And then coming back to the UK, getting a taxi across London and thinking, well, that would not work here. You wouldn't last 2 minutes in South London, mate, with your school kids running out and your cyclists and your scooterers and people all over the place. So how can we scale up autonomous systems? How far off are we, autonomous systems really being able to operate in the kind of chaotic environment of cities, or are we going to have to re-engineer the environment to suit the robots? Let me start with Jonathan, and then I'll come back in.
Yeah, and so the autonomous vehicle the autonomous vehicle domain, the evolution of these wonderful machines that are going to take us from A to B without us worrying about them at all. It's kind of a test bed for this kind of humans interacting with robots thing. Because at the moment we have humans driving cars, and they've learnt that behavior when you come to a traffic light, what to expect the other person to do. And we always have an interaction, you kind of try to take the advantage. And that's fine when there are humans around. If, on the other hand, you could imagine 50 years down the line when they're all driven by robots, or they're all autonomous, then that's fine because a computer can schedule all of the interactions. And we don't have to worry about it because there's going to be no crashes because one big or lots of computers are going to schedule it. It's that kind of intermediate period where we're going through this understanding of how autonomous systems and humans operate together so that when me as a driver and I as a driver come up to a traffic light and there's an autonomous vehicle, we have a safe interaction. Because I know what's going to happen. I'm going to see that autonomous vehicle. I'm going to try to predict what it does, and I'm going to try to take the advantage in the traffic light. And so there's a potential for all sorts of conflicts to go on. And then that vehicle is going to try to learn what I do, and it's trying to learn what I did when I was interacting with it. And you can imagine how complicated this is going to be. So the evolution of autonomous vehicles is a really nice testbed to see how things are evolving before they actually get replaced with completely autonomous machines. The trouble is, or the opportunity is, when we're interacting with other robots in other situations, we're going to be continually interacting with them because they will not be replacing us. So for example, if we go into a shopping mall, in that kind of environment, there'll be robots helping us, and in the future, they'll be all around helping us, and we'll be continually interacting with them. We won't get to a point, I don't think, not for a long time, when they completely replace us. Autonomous vehicles, yes, they will replace us because it's the safest thing to do, and that big Google machine with its satellite will be able to schedule us. The interesting thing is what happens in that medium term. I don't have an answer for this, but it's going to be very exciting.
Okay, so any answers over on this side? How can we scale up the autonomous systems to operate in very complex environments?
What I can report to you is interaction with several of our industry collaborators that are sharing Jonathan's view, really. In the next few years, what we're going to have is always some level of teleoperation, which is already a challenge. When you think about all the possibilities of a robot that is acting in the real world, interacting with humans, completely unpredictable, there will always be situations where, oh, we have a problem here. We have something totally unexpected. We need to hand over control. And so teleoperation as a stepping stone to get to that level of autonomy where we're wondering whether just because they need power is it autonomous or not, is a little bit far. There is this, which is still very exciting, it's still very hard. We always try to push further and further the level of autonomy.
Did you want to chip in on this?
I have a clever solution for this.
Okay, if you're watching, you have a clever solution, write in now. Another huge question, I love it when people turn. I once chaired a robotics event in Moscow, and the first question from the floor was, when will robots have a soul? Yeah, I know, impressive. It's all the British roboticists there were saying, well, we're some way off being able to both make tea and walk upstairs. No, the Russians are straight in. When are they going to have a soul? So this question is not quite that far out, but still quite philosophical. Do you envision an autonomous system to have its own consciousness? Any yeses here?
What is consciousness? That's the obvious retort to a question like that. To me, I think if you ask ChatGPT to have a conversation with itself, maybe I'm too simple, but I can easily believe that that's a fairly human conversation in certain instances. Not all the time, it makes mistakes and so on, but humans make mistakes too. So is that conscious? I don't know. It just depends on definition. I agree with Michael who's shaking his head that is not consciousness. But I think we're coming to the point where some of these systems are testing our understanding or our definition of intelligence, of consciousness. There's a lot of information on the internet. If you amalgamate it and present it to you, is that better than the average intelligence of a human? I don't know. I don't have an answer, but these are the sorts of questions that I ask myself sometimes, and I think the answer is becoming less discernible than it would have been 10 years ago.
Okay, so we can answer that question worse than 10 years ago. This is a first. Any dissent here? Anyone think that it does or will in the foreseeable future have consciousness?
Its definition of consciousness is quite difficult. We're building systems that have things that sound human, like they have goals, they have beliefs, they have self-awareness, so they can work out what they're doing and why they're doing it. Ooh. At what point do we call this consciousness? Again, I'm not a philosopher or a psychologist, so I can't say, but they have all these aspects that you might think are part of consciousness, maybe not reaching whatever the magic thing is yet.
Okay, so maybe we need to reconvene this with philosophers.
Yes, theologists.
Theologists.
Yeah.
Okay, on to the next question. I'm now going to try and get in as many as we can because we are sort of moving towards the end of our time slot. And this actually picks up on something you mentioned earlier. How can robots be made more energy efficient and sustainable?
Ooh.
I could go for that since I'm involved in a standard on sustainable robotics, and they're yeah, I know. That was made for me, that question. So again, it's a guidance about when you're building a robot, making sure that you're clear about where you get the materials from the robot, how you fabricate the robot, how you deploy the robot, but also when it's deployed, how you make sure you minimize the energy it uses. Is it collecting vast amounts of data, and is it shipping them across the world to a cloud server? All these things are bad for the environment. And also, at the end of life, can you decommission this robot? Can you recover it? Can you make sure that the world is the same as it was before the robot was there, in some sense? But reducing the amount of energy, for example, that robots use is really important. So work on simpler versions of AI, or green AI, which is less resource intensive, will help you get towards that goal. You're never going to reduce it completely, but using as little energy as possible and collecting as little data as possible to do what you need to do. That's the sort of key step we're trying to push.
Any other hints? We're going to recycle our trousers. That's obviously going to help.
Well, we make sustainable robots in that kind of physical sense. So we make robots in my lab out of biodegradable material, even material that you can eat. So there's a prospect of making edible robots and robotic food. Why shouldn't the food on your plate be robotic? Why not? That's surely sustainable. That's the ultimate in sustainability, because when you throw it away, microbes in the environment will eat that material. Also, the robots take energy from the environment by themselves, eating food, as we talked about earlier, from the environment. So it becomes a very nice robot ecology in the environment. The one interesting thing I find fascinating about this is that changes the way in which we think about robots being deployed. At the moment, we might make 10 robots, rigid metal robots with batteries inside them, put them in the environment, they do something good, they collect pollution or something, but we have to bring them back to base, otherwise they themselves will pollute the environment. So if you turn that on the head and you say, but if you can let these robots be biodegradable in the environment, you don't have to collect them. So you could just throw them out there in the millions, the billions, the trillions, because you know that they're going to do some good, and at the end, they will degrade into the environment. The bugs, the animals, the turtles, whatever, will eat them completely safe. So it changes the way in which you think about these kind of sustainable robots. So the stuff that Michael does is very high level, and the stuff that we do is very low level, and the two are coming together.
Okay, good. Oh, that's a very, very broad answer to that. We are rapidly running out of time, but I really like this question from Mehul. Apologies if I'm pronouncing your name wrong. What will robots look like in 200 years? Is a Star Wars Star Society with droids and humans interacting a possible scenario? I mean, you kind of, you hinted at that in a vague general way, that we would be living alongside robots, but I'm going to ask you now to throw your imagination forward 200 years. If you can, in fact, let me put a little bit of pressure on, because we've only got a few minutes left, so this is probably going to be your last answer. Imagine the work you are doing now, right? 200 years' time, somebody will be sitting in, I mean, who knows what the space will be like. We'll be streamed as holograms or something, discussing and saying, well, of course, you know, little did Ana Cavalcanti realize 200 years ago that her work would result in. So come on, what's 200 years' time? This is your work down the track has transformed the world. What does it look like? Is it like the bar in Star Wars? What's it like, Anna? we're gonna put you on the spot and start with you.
Well, I can tell you that I hope so. I hope that the future is a future where we have lots of machines, friendly ones, not the Klingons. Friendly machines. Friendly machines helping us to live a better life, revolutionizing the way we manufacture, revolutionizing the way in which we interact with each other, revolutionizing the way in which healthcare is provided, agriculture. We have a great challenge in terms of food crisis if the population continues to grow. So there's a lot that we can do for agriculture. So who knows what's going to happen in 200 years, but I hope that the visions for all the wonderful applications that we as a research community can envisage will become a reality. It will be a much better world.
Fantastic. Michael, what about you? What's your work going to seed in 200 years? We will be sitting here discussing.
All the robots will have screens on their chest where you can tell what they're doing. But if people are happy that robots look like people, then a non-dystopian version of things like Blade Runner, where you can't tell the people from the robots, maybe a future. A non-dystopian one, the good robots.
But hang on, the robots will have screens,
Yes.
so we'll know what they're thinking.
Yes.
Does that mean the people will also have screens by
No.
then?
You better tell the difference, but from physical and interaction, you can't really tell the difference. Maybe that sort of future, but it's a long way away, and I have no predictive powers at all.
Okay, so robots look like us, except we can tell what they're thinking.
Yes.
Well, I think that robots should be a democratizing technology, right? So if you take all the people in the world who are disadvantaged, like Anna says, then certainly they can impact across those domains. Things are going to look different there, I think, in terms of society. But personally, I'd like a couple of extra arms maybe coming out like this. I've always thought the tentacles are quite nice. I quite like octopus tentacles around here, maybe holding a couple of pints of beer. We're going to be augmented ourselves. We're going to be advanced in our bodies, but also in our capabilities. So for me, that's exciting. I also will look younger, I hope, as well.
I'm liking this. It is actually starting to sound a bit like the Star Wars bar. We've got the robots look like people, except we'll know what they're thinking. The people will look like many-armed deities. So Dan, here you go. You get the last word on this expert panel. Throw us forward 200 years. What does the world look like, and what of it are you going to claim the credit and say, I started that?
I think Jonathan just described Dr. Octopus from the Marvel movies. I think it's hard to pitch yourself against the fantasy of George Lucas or Stan Lee. So I'm just going to go wild bet. I think we'll be closer to Star Wars than to Lord of the Rings. And my contribution to it, probably none.
No, I'm not going to allow this kind of defeatism at all. You come on, you're working on the all-seeing eye of Odin for a start. Come on, I won't.
It'll be a
all right, then.
Prometheus capsule.
I will let you off the entire world. What's the entire world going to look like? The work that you're doing with medical robotics, like what, be optimistic here. It's like 200 years' time. What will the difference be to our lives?
Well, I'm hoping medical procedures won't be happening in the Star Wars bar, but I'm 100% certain that all medical procedures will involve both robotics and AI. So all instrumentation will have a robotic component. The type of imaging we use will be AI enhanced. There'll be technology ubiquitously present in all healthcare interventions.
There you go, a nice, solid, down-to-earth, practical. And I think this is a very good note to end on. We've got a lovely, optimistic vision of the future, everything from actually really effective, reliable, accessible, cheap medical procedures, augmenting our bodies as we wish. At least half the population, we will know what they're thinking. So that's an improvement on now, right? And we will just generally be living a life alongside machines where life is easier, longer, healthier, happier, more interesting, all thanks to robotics, autonomous systems, and especially to the chairs of the Emerging Technologies Award, especially thanks to the Royal Academy of Engineering. So I think on that note, I'm going to thank you all for joining us, and whether here in person or virtually on the live stream, or even in the future, go on, indulge in a little bit of mental time travel. I'd like you to thank our excellent panel for answering not all of the questions, I'm afraid, but as many as they could, and throwing us into the future. Thank you all.